Hi everybody. So in this video, we're going to talk about Avogadro's number. So Avogadro's number is 6.022 times 10 to the 23. Not precisely, there are a lot of other decimals we can write after this. But it is a pure number. In other words, it has no units. So it's kind of like a dozen. Now, we give a name to Avogadro's number. We call this a mole. And saying that you have a mole of things is kind of like saying you have a dozen. So just like 12 is equal to a dozen, then in the same way, 6.022 times 10 to the 23 is a mole. And you can have a dozen eggs, a dozen donuts, a dozen atoms. The same kind of thing. You can have a mole of eggs. It would take you a very long time to eat those eggs. But you can have a mole of anything. So a mole of something just means that you have this very large number, 6.022 times 10 to the 23. Now, when you have such a large number, that's useful for counting things that are really, really small. So, of course, we're going to use mole to count things like atoms or electrons or protons or anything that's very, very, very tiny. For us, for the most part, we're going to use moles to count atoms or molecules. So that's where it comes in handy. Now, when we talk about a mole of something, we want to be able to connect what we measure to a number. This is where Avogadro's number becomes very, very powerful. It's a very powerful tool. Now remember in a previous video lecture, we talked about the element lithium, and lithium can come in two different flavors. It always has 3 electrons in its nucleus. If it has 3 neutrons, then it has an atomic weight of 6. I think I misspoke. It has 3 protons in its nucleus. If it has 3 neutrons as well, then it has an atomic weight of 6. And if it has 4 neutrons, then it has an atomic weight of 7. Now, in the natural world, lithium has an atomic weight of 6.941. Now, this number does have units. This is the atomic weight that you would see in a periodic chart. And in that atomic weight, the units are grams per mole. And this number that does not come out to a whole number just means that when we look at lithium in nature, most of it's lithium-7. It's very close to 7. But there's enough lithium-6 in nature to bring that number down a little bit. Enough of a percentage to give us a natural value of 6.941. Now, here's where Avogadro's number becomes very important and very powerful. By saying that natural lithium has an atomic weight of 6.941 grams per mole, that means that if you measure out 6.941 grams of lithium, you will have 1 mole of lithium atoms. That's really a startling thing. You can count atoms by weighing them. So having 6.941 grams means that you will have 6.022 times 10 to the 23 atoms of lithium, which is 1 mole. And we could do this with anything. Let's take something that's a little bit more familiar. The atoms sodium and chlorine can bond together to give us the mineral halite, sodium chloride. So here's the mineral name, halite. Sodium has an atomic weight of 22.98977 or something very close to that. Chlorine is about 35.453. And so for halite or sodium chloride, we can add those two things together, and the molecular weight that we would get is about 58.443. We'll just round it off to 3 decimal places here. Now, all of these have units. These are units of grams per mole. And so what this means is you can do a very simple experiment that I would like you to do at home. what you should do is when you go home, you should take a scale that you use to weigh out foods. So here's the bottom panel readout, and you should get some salt, a large amount of salt in a container, and start pouring it out, pouring those salt grains onto that scale until the readout reads 58.443 grams. Make sure that the unit is reading in grams, because a lot of scales have a default value of ounces. So when it reads out to 58.443 grams, what does that mean? You could take a look at that pile of salt that you've just poured out on the scale. And the beauty of Avogadro's number is it tells you, once you have the weight correctly measured out, that you know exactly how many molecules of sodium chloride or how many atoms of sodium and chlorine are in that pile. To give you 58.443 grams of salt or halite, that means you have to have 6.022 times 10 to the 23 sodium chloride molecules. And to make 6.022 times 10 to the 23 sodium chloride molecules, you need an Avogadro's number, 6.022 times 10 to the 23 sodium atoms, and the same number of chlorine atoms. So altogether, there are 2 times Avogadro's number of atoms to give you 1 Avogadro's number of sodium chloride molecules that consist of a mole of sodium and a mole of chlorine. So by weighing that out, you'll be able to stare at that pile of salt and realize that you now know exactly how many atoms and how many molecules there are in that pile of stuff, which is a very, very exciting thing to do. If you don't think that's fun, then you do not know what fun is. It's a very exciting experiment that you should definitely do.